Hello guys, Winston here. Epoxy is one of those materials I've long been interested in getting into, but it had to be on my own terms. We're all familiar with river tables and resin art, and while I appreciate those kinds of things, I really have no interest in following in the footsteps of thousands of other makers before me. So, when Total Boat offered to send me some epoxy to play with, I was thrilled. But I knew I'd have to come up with a project that felt true to my own interests, and that meant not making a tabletop. I was ill-equipped to make something that large anyway. Plus, this being my very first epoxy project, I was bound to make some mistakes. And in the event that I had a catastrophic mishap, I wanted to fail fast and fail small. For inspiration, I immediately looked at the disheveled state of the horizontal surfaces in my room. Recalling the satisfaction of having a container on my monitor stand in which to corral loose objects, I decided to make a catch-all tray or valet tray. My design philosophy going into this project revolved around two basic ideas. One, epoxy is not cheap. It should be applied in a way that minimizes waste. Two, epoxy as an inlay isn't creative. Now, I'm not trying to imply that anyone who's poured epoxy into machined pockets or text for something like a sign suffers from a creative deficiency, but we all know that a liquid will flow readily into crevices. The technique is not what makes those projects interesting. Good design and execution matters far more in those cases. And not only am I not good at making two-dimensional designs, but like I said before, my skills working with epoxy are lacking. I wanted to be challenged by the execution of the project, not necessarily the aesthetic design of it. I am, after all, a hobby machinist first and a woodworker second and an artist third. So I'm really not content to machine a wooden rectangle with a simple pocket, V-carve some words or a logo in the bottom and flood it with epoxy. A chimpanzee using Carbide Create could make that. But what if I flipped that recipe? What if I made the epoxy an integral part of the tray and treated the wood almost like an inlay? That seemed like a more promising way to go. That idea was actually inspired by a tabletop I saw on YouTube that I really liked. It's the Bog Oak and Epoxy Resin coffee table, which has an epoxy pour that makes it look like wooden hexagon tiles are floating within an ocean of blue resin. Yes, it is using epoxy as a filler material to bridge discrete pieces, like a river table, but those pieces are deliberately positioned and unnaturally patterned. Not only do I find that more visually interesting than live edges separated by an arbitrary span of resin, but it's also closer to something that would afford an opportunity to utilize my CNC. So with that inspiration, I decided to make a tray where my logo would be floating within the epoxy. I sketched up something that had my logo centered and a stripe of epoxy across the bottom, but I really wasn't thrilled with that first draft. If you have a flat panel of epoxy at the bottom of a tray, everyone and their grandma would be able to figure out how you did it. I really did not want to make something that could be made with 2.5D machining strategies. But if I could make that interface between the wood and epoxy a little more dynamic, less planar, I surmised that the end result would be a lot more interesting. After modeling a rectangular tray, I created a 3D surface that had some gentle symmetric curves in it. This surface became the tool I would use to split my tray into a wooden half and epoxy half. I modeled the negative of my tray with about 1 millimeter of margin around where the tray would be, and when I combined that with my splitting surface from before, I would have a mold for the epoxy half of my tray. If I additionally extruded out my logo in reverse, I could embed it in my epoxy pour, perfectly positioned, and without needing to glue anything down to prevent pieces from floating away. And since I had already put this much work into the CAD, I figured I would make a few more trays. One of them would have the Carbide 3D logo, and one of them would be for my buddy Chris, who's helped me before with a couple CNC related things. The cam for this mold was pretty simple. Step 1, drown the mold cavity in some carefully constrained 3D toolpaths. Step 2, well, that's basically it. 3D pocketing was used to rough out the mold. No adaptive toolpaths here because to go around this dumb narrow channel would have meant a lot of tiny time-consuming arcs. Plus, this is wood, which is not all that challenging for a router. I followed that up with some 3D finishing toolpaths to hit the vertical, flat, and sloped regions. By using 3D toolpaths that are model aware, I could create multiple setups of the same operations and generate toolpaths for different trays with just a few clicks. All I would have to do is include different sets of bodies in each setup corresponding to the logo I wanted for each tray. The 3D toolpaths would automatically calculate around whatever new bodies I had selected. I also generated a program that would bore a set of locating holes in my stock for the inevitable secondary operations. Setup 1 would get me to the point where I could pour my epoxy and cast the bottom of the trays. Setups 2 and 3 would be run several days later after the epoxy had set, cutting out all the external features of the tray, since after pouring the epoxy, I would be back to a solid rectangular brick of material. It should have been a slam dunk, or so I thought. In my garage, I began by cutting up some lengths of maple and surfacing those boards. Flat, even stock is one of those fundamental things you need if you want to have a consistent CNC experience. Once I knew the boards would sit flat on my wasteboard, I could tape them down with confidence that they would be secure. I went through my roughing operations one by one, and anytime you're doing multiples of something, it's the perfect time to try different toolpathing strategies and improving your speeds and feeds. Around the perimeter of my mold cavity, for example, I had initially used a radial toolpath. Not only did I want to avoid a tool change to a ball end mill, but I needed a flat end mill to get the sharpest corner around the perimeter. A flat end mill going with the gradient of the slope gives you the smoothest results without the stair-stepping you would get from a predominantly horizontally moving toolpath. But the speed of the radial toolpath left a lot to be desired since it required a lot of direction changes, and the Shapeoko's accelerations are set pretty conservatively. Since my mold was designed with a small bit of margin around the tray, I concluded that a scallop toolpath would be good enough. The magnitude of the stair-stepping would be small enough to not show up in the finished piece. Even though the fusion estimate for these two finishing strategies was similar, in actuality the scallop was noticeably faster. With 3 tray blanks machined, I pulled them off my Shapeoko and prepared for my first ever resin pour. Because I had a fusion model of my maple blank, I could accurately calculate exactly how much epoxy I would need for one tray, in theory. I mixed up enough TotalBoat thickset epoxy for one tray to validate the estimate. I mixed in some black diamond mica pigment powder in green envy to color my epoxy. It wasn't really an active choice, it was just what I had on hand because TotalBoat was handing out free samples last year at WorkbenchCon, and I knew I would get around to using them eventually. See, not hoarding, just extremely good foresight. After pouring epoxy for one tray, I went out to lunch, and when I came back, I noticed that my pour had sunken in slightly around the corners. Epoxy typically shrinks a couple percent by volume as it cures, plus I suspected a tiny amount had seeped into the wood grain itself since I hadn't sealed my maple and there was a lot of exposed surface area. So just like with metal casting, you'll want to have a small amount of excess or a reservoir of epoxy that can flow in as it sets. Also, it helps if your work surface is level. I mixed up enough resin for the last 2 trays in a container that was probably too small for the job, but whatever. At the end of day 1, I had 3 epoxy pours curing. Now, because of the timing of this project, which I'd started just before the holidays, I actually didn't get back to these blanks for several weeks. And in that time, my maple had acquired a small bow. They no longer sat flat. I tried holding these steady with cam-style clamps on my CNC so I could face at least one of the surfaces flat, and the clamps held them securely laterally, but there just wasn't enough friction to guarantee that the blanks wouldn't shift vertically or rock back and forth. But when I finally got my hands on some of Luke's new gator tooth clamps, which have provisions for an angled screw in the back, I rejoiced. That grub screw could bite into my stock and fully constrain the workpiece. Of course, with how much I'd planed down my boards, I was getting dangerously close to the top surface of the clamps, but if you're securing 3/4 inch boards, the 18mm height of the gator tooth clamps should be much easier to clear without giving yourself a heart attack. While I had my stock secured and its position known exactly because of the indexing pins I was using, I cut out the tray from the bottom. First, I faced my stock flat again since I had a giant epoxy scab on top of my maple. With the face of the epoxy flattened, I could run through some roughing toolpaths with a 1/4 inch flat end mill. I contoured around the epoxy, leaving healthy-sized tabs to keep the tray in place. I also roughed out the fillet around my tray's bottom edge, using plenty of stock to leave. If any sharp horizontal marks were left in my tray, I would have to do a lot of sanding to get them out. That fillet around the epoxy edge was larger than the largest roundover bit I had, so I had to let the CNC take care of it. A 1/4 inch ball end mill handled it just fine. There was a little bit of faceting or orange peeling in the surface finish, but I could blend that in relatively easily by hand. At this time, I also realized my biggest mistake with the epoxy. Since I hadn't sealed the faces of my maple before pouring, I had a lot of air inside the wood fibers escaping into the epoxy, forming bubbles. The right way to do this would have been to lay a really thin coating of epoxy on your surfaces, letting it work into the wood for a few minutes, allowing any bubbles to form and be popped before pouring in the rest of your epoxy. Or you could also do it the quick and dirty way and use a lacquer or polyurethane spray coating to build a barrier between the wood and the epoxy. Either way, I hadn't done this and now had to contend with some exposed bubbles and voids in my epoxy. Whatever, that would be future Winston's problem. I had more pressing concerns to deal with. As I was machining my last tray, one of the end mills started slipping out of the collet. It probably hadn't been tightened down nearly as much as it should have been. That increasing depth of cut as the end mill pulled out of the router caused forces on the spindle to increase, eventually causing some chatter that was visible on the walls of my tray. To cover that up, I quickly duplicated my tray model and made a variant with thinner walls. I ran the finishing toolpaths for this model, which trimmed away enough material to erase those chatter marks. Then I had to deal with flipping my parts over to mill out the main pocket of the tray. But keeping my trays tabbed to the rest of the stock wasn't going to work, because that was a relatively weak connection. Plus, I wanted to round over the top edges of my tray on the CNC, so I couldn't have tabs in the way. I didn't trust the bearing on my roundover bit to do well on my relatively shallow tray's walls. So I machined a snugly fitting pocket to locate my partially completed trays and used double-sided tape to hold them down. The majority of the forces during machining would be lateral, as I was going to rough out the pocket with my bowl bit, which is effectively a straight fluted cutter. I started with my smaller tray first, since you can open up a pocket but not shrink it. The pocketing with the bowl bit went great, though the surface finish on the floor seemed unexpectedly poor. I then loaded up this corner rounding end mill from Melon Tools and went around the top edges of my tray. I didn't get it absolutely perfect, as you can see a small line where the edges of the corner rounder didn't match up exactly with the top of my tray, but that wasn't the end of the world. A little sanding would fix that. As I pulled out my first tray from the pocket, I noticed that it wasn't sitting perfectly flat on the bed of my CNC. Recalling that my maple had bowed in the several weeks long span between when I'd first poured my epoxy and when I was now machining my trays, it was likely that there were some internal stresses within the maple and epoxy that were now being released. The better order of operations here would have been to machine the bottom of my stock and tray flat, flip the stock over to hollow it out, removing the bulk of the material before anything else and letting the material take whatever final shape it wanted to, and then machine the bottom of the tray last so it would be able to sit flat. That bottom face is really the only important interface that matters for this tray. Whatever, I could always stick on some little cork pads or feet to level this tray out. I widened my locating pocket for the remaining trays and ran through the same operations. Things were a lot better with these two because the walls and floor were left thicker. When all my machining operations were done, I sanded the trays to about 400 grit on the inside and outside. The outside of the trays was easy to do, but the inside was slightly awkward to get to because it was concave. Because I wouldn't be able to polish up the inside of that pocket, I would use Total Boat's tabletop epoxy to form a self-leveling skin over my tray. That would fill in all the scratches and unevenness in my epoxy and leave it smooth and glossy. Now, one of the things I wasn't really sure about was how to blend two different applications of epoxy. I've googled epoxy tabletops a bunch of times before, but I've never seen if or how people finish the undersides of tables. No one ever seems to talk about it. I wanted to cover this tray on all sides, so at least one of the faces of the tray would have to be left bare initially, and then afterwards I'd have to come back to apply a last coat on the remaining face or faces. I wasn't sure if there would be a noticeable seam between two different coats of epoxy, or if they would sort of blend themselves together. There was only one way to find out. I opted to do the inside first. Using a foam brush, I applied a generous coating of epoxy to the walls and floor. I also left a really thin coat around the outside of the tray for blending purposes. Here, you can see some of the exposed end grain was releasing air into the epoxy, forming bubbles. I had to babysit this tray for about 10 minutes, popping bubbles with a heat gun, until the viscosity of the epoxy started increasing and the air pressure in the wood equalized. I also had to drip on some epoxy in some of the holes around my logo where bubbles had initially been formed. I probably should have filled these with some CA glue before applying the epoxy, because even with my applications of extra epoxy, tiny sink marks would still show up on the surface. 2 days later, I came back to scuff up the outer walls of the tray. In some areas where there were drips or runs, I had to do a little more substantial sanding. I applied a thick layer of epoxy on the bottom face of the tray and an extremely thin coating on the walls, hoping that it would merge with the previously applied epoxy. And for the most part, it worked. The transition between the outer walls and the top lip of the trays isn't seamless, but you really don't notice it unless you're touching it. From any more than an arm's length away, or unless the light reflects off the surface at the right angle to illuminate the imperfections, these trays look like trays, and that's fine by me. These pieces were intended from the get-go to provide me ample experience working with epoxy, and in that sense it's 100% mission accomplished. I do like the thicker trays more than the thinner one, as that one is just a bit too transparent, but that's something that could be fixed with more pigment powder next time, or by not screwing up in the first place. and the fact that these trays aren't perfect means I have zero qualms about abusing them, and I really don't care about scratching them up. So all in all, I'm pretty happy with both the design and the function of the end product, and I also have a list of lessons learned that I can implement the next time I work with epoxy. I want to thank you all very much for watching, and also thank TotalBoat for loading me up with some awesome epoxy products to play with. Learning to work with this stuff opens up a bunch more project options for me, so I'm glad I got a lot of the beginner mistakes out of the way here. If you have a favorite tip or trick for working with epoxy, leave them for me in the comments below. I'll be back soon with more CNC projects and DIY nonsense.